Okay, lesson 23, laws of logarithms. So, in order to get into laws of logarithms, I just want to kind of quickly remind you guys about some of our exponent laws that you guys have been doing for a few years now. So, if you remember, if we have something base a times to the power of m, or whatever, just some number, times a to the power of n, then we add the exponents. Something similar, if you're dividing, we'd subtract the exponents. If you go a power to a power, we multiply. If we have a to a negative number, then we take the reciprocal. And then the other one was a to the power of 0 is equal to 1. Okay, we've been using those a lot, so I'm not going to spend any time on that. But the reason why I bring it up is because now we're going to be doing log laws. And they're actually just going to be like the flip, right? So when we went, so we had something like a to the power of m times a to the power of n, and we added those. We're just going to be doing like the exact opposite of that when we're dealing with logs. So if we're adding, then we're going to turn that into multiplying, right? So that's kind of where we're going here. So you guys have these on your formula sheets. Can you guys actually get your formula sheet out so you can kind of see, like they look a little different maybe, but okay. So you guys will see that we don't have all of these ones. We don't have the first two on your formula sheet, but that's kind of okay. The first two aren't really laws anyway. These ones are kind of just like applying what we know about logarithms already, right? This first one's really just saying, well, log base b of 1 is equal to 0. Well, that you can kind of just make sense of that by saying, okay, if you wrote that in exponential form, that would be b to the power of 0 is equal to 1, which, yeah, that makes sense, right? Anything to the power of 0 is 1. And then the second one we've been dealing with too, right? This would just be saying b to the power of 1 is equal to b, right? That exponential form. So yeah, that makes sense, so that would be equal to 1. Now the new ones will be these ones, right? So here's our product law for logarithms, where if you have log base b of some number times some other number, or x times y, like variable times variable, you can split that up as log base b of x plus log base b of y. Do you guys see how that's really just kind of the opposite of our exponent law, our product exponent law? We like turned our multiplying into addition. Now we're kind of just doing the opposite there. Yeah, okay. So same thing with a quotient law. So we're going to have, so if we divide, that'd be the same thing as just subtracting them. And then the reciprocal, actually, yeah, we don't have this one either. But do you guys know how this one would make sense? If we had log base b of 1 over x. Actually, sorry, you know what I'm going to do? Let's explain the powers one first. So the powers one is on your formula sheet. So this is just log base b of x to the power of n is the same thing as the n just being down front, like out front there. So I quite often will just draw it, like put a circle around it and like bring it out front. So it can be written that way. And that one relates to our power law, right? So it comes from the same place. Okay. Now, if I go back to the reciprocals one, the reciprocals isn't on your formula sheet, but it'll make sense because if we had log base b of 1 over x, well, that would just be the same thing as log base b to the power, or of x to the power of negative 1, right? And then using our powers law, we can just bring that thing out front. So that'd just be negative 1, bring that out front. So that's how we would end up getting the same thing there. Is that... Sorry guys, I'm not sure when I stopped recording. We've moved on to this one. So we're just doing the top part here, expanding it. Yeah, thanks for the heads up. All right, so now let's handle the bottom. So the way you could think about this is we could say, okay, this is now minus, like the bottom part. So this would be minus, in brackets, log base 4 of 4. And then adding them because they're together, right? I'll simplify this in a second. I think we'll find an easier way, but I just want to lead up to it. So it'll be plus log base 4 of z. You guys gonna follow on that one? Okay? Now, that negative here, right, we're going to distribute that negative onto both of them. So we'll write it all again. So this would be log base 4 of... Actually, you know what? Just to save time here. On this first one of our log laws there was that we could bring this 3 out front, right? So let's just do that now. So that'll be 3 log base 4 of x plus log base 4 of y. And then I'll just put that minus on both of them. So minus log base 4 of 4. And then minus log base 4 of z. Okay, so I did more than I had to there. I wanted to show you guys that in that step on the top there where I went minus the bottom part, do you guys kind of see the pattern that we're just going to add it if it's on top and we're just going to turn it into a minus sign if the thing was on the bottom or in the denominator? Okay, so you didn't need to do that first step. You could just write it all out in that first step there. Okay, now let's just kind of write it out one last time. Do you guys see anything else we can simplify here? Yeah.
Isn't log 4 of 4 just 1?
Yeah, exactly. We could just call this 1, right? Log base 4 of 4 is just 1. Yep.
And that would go with
okay. Okay, so then we'll write it out one more time. Log base 4 of x plus log base 4 of y. And then I'll write the 1 at the end. Typically, if you just have a constant, you just put it on the end. So I'll write minus log base 4 of z. And then minus 1. Okay, next one. So throwing a square root into it, which I haven't talked about square roots yet, right? But typically, whenever we're doing algebra on radicals, we want to turn it into an exponent, right? We know what to do with exponents with our exponent laws when it's written in that form, right? So very first step, let's get rid of the radical and let's rewrite this as log base 7 of, and I'll put this in brackets, x to the power of 2 times x to the power of 3. And then how do you write a square root as an exponent? 1 over 2, right? This is probably worth reminding you guys about. If I had, like, let's say 3, let's say the 5th root of 3 to the power of 4. Do you guys remember that little pattern there? That'd be the same thing as just 3 to the power of, and then it's just the power is the top and the root is the bottom. So like 4 over 5 in that case. So square root would just be, because this is 2 into the power of 1, so it'd be 1 over 2, right? Okay. All right. Any ideas on what we should do next?
Multiply.
Yeah, let's actually apply this 1/2 to these other exponents, right? Just to make it a little bit simpler. So we could write this as log base 7 of, and then x to the power of 2, and then when we have a power to a power, we multiply, right? So that's going to be x to the power of 2 over 2, or just x. And then y to the power of 3 over 2. All right, so I think it's kind of set up now. Now we're going to apply our log law. So should I have more room here? I'm just going to put an arrow there. This will turn into log base 7 of x plus log base 7 of y to the power of 3 over 2. Now we typically don't like to leave any exponents in these, so what's my very last step I can do here? Yeah, we can bring that 3 over 2 out front. So that would just all be log base 7 of x plus 3 over 2 log base 7 y. All right, I'm going to pause it. Can you guys do the next one? All right. Now, next part, we're just going to go the other way, right? So now it's written all expanded, and we want to write it in the other form, right? So first thing I'm looking at on these questions is to make sure that they all have the same base, right? Because if they don't have the same base, I can't combine them. Okay? So it's going to be log base 2 of something. And then like I was saying, if really an easy way to do this is if it's a positive, it's going to go on the numerator. And if it's a negative, it's going to go in the denominator. Okay? But just to make a bit more sense here, I'm just going to write this out one more time. And I'm going to get these all looking like exponents first, right? Like I'm going to write this a little different. I'm going to write this a little different. And then maybe I'll do that. That's on the next step. So log base 2 of x to the power of 3 minus, and then this could be rewritten with the 4 put back up on top of the exponent, right? Just going the other way with that. Okay, so that would be log base 2 of x to the power of 4, and then minus log base 2 of, and then this would just be x to the 1/2. And now I think it's kind of set up, right? Now we can just write it all together. This would be log base 2 of, so this was positive, so it's going to go up on the top. So x to the power of 3. And then these are both negative, so they're going to be down on the bottom. So this will be x to the power of 4, and then times x to the 1/2. Now that's it, but we wouldn't typically leave it that way. So we'll use some more exponent laws on the inside here. Let's combine those. Just to simplify it a little bit, this would be the same thing as log base 2 of 1 over x times x to the 1/2. Or like I just combined the x to the 3 and the x to the 4, right? So there's just one left on the bottom. And then what do we do when you're multiplying and you have the same base? We add them, right? So really this is x to the 1 on the bottom. We could just write this again with that still on the bottom. This would be the same as log base 2 of 1 over. And then this is where you need a common denominator, right? But I'm guessing some of you guys might be able to do this one in your head. This would be x to the power of 1.5, but typically we want to leave it as a fraction. 3 over 2. Yeah? If you had trouble with that, all I did is in my mind, I just changed that 1 to a 2 over 2, and then added the numerators and kept the denominator the same, so that would be 3 over 2. Okay, and then we could just leave it like that, or you might also see it written as log base 2 of 1 over, and then we could write this as the square root of x to the power of 3. Some of you guys are thinking, but didn't we learn in 20-1 that we should rationalize denominators? That's true. You probably should, but we're not going to get into that. We can leave it like that for now. But you could rationalize that denominator but
Why would I want to?
yeah, sorry, that's the 3. It was getting kind of hard to write there. It was x to the power of 3 there. Okay. Here, I'll pause it. You guys do this one. Okay, so if you're just watching the video, that was our answer. All right, so this one. So now, got the same base. So we should be able to just combine these the way they are now, right? So we'll just write this as log, knowing it's really log base 10. And then so if we're adding, we're going to combine those things by multiplying, right? So we're just going to write it out again now as x minus 3. Here, I've got a bracket and then another bracket like that one. And then x plus 4. Bracket. Sometimes you guys might want to use square brackets on these, just to make it a bit more clear. And that's pretty much it, right? Other than, we probably wouldn't leave it that way. probably want to expand it out, so that'd be the same thing as log of x squared plus x minus 12. Just expanding that one out. Okay. Then we just get a little more tricky as we go. So this one says, first simplify the logarithmic expression into a single logarithm, then evaluate for the given value. Okay, so this would be the same thing as log base x of, and then we're adding, so I'm going to call this, so this would be 10 times 75 up top. And then my little trick there was, if it was positive, it was on the top, if it was negative on the bottom. Just be careful on this one, right? Because if you distributed that negative, they both be on the bottom. So this will be 2 on the bottom and 3 on the bottom. Okay, so that is equal to log base x of, the top would be 750 over 6, which would be the same thing as log base x of 125. Okay, so if we had this expression, especially with like log base x, this would be kind of a tough one to figure out if we didn't simplify this. But now looking at it, we should be able to like just convert this thing into exponential form and then just kind of use our reason to figure out what x would have to be. So it says x is equal to 5, right? So we'll just rewrite this as log of 5, log base 5 of 125 is equal to, what would that be equal to? 3, yeah. Yeah, 5 to the power of 3 is 125, right? Because that's really saying 5 to the power of what is equal to 125 when you're looking at that. Yeah.
If you wanted to, though, couldn't you just type that?
Okay. You know what? For the sake of time, I'm going to leave it at that one. I think you guys will be all right. Let's move on to the next one there. All right, so here's a specific type of question, and it's kind of unique, I think, to like Math 30-1, where they're kind of like little puzzles. So using what you guys know about log laws, they give you a little bit of information, and you have to like, yeah, it's like a specific style. So this one says determine the value of this if P over Q is equal to 16. So now this P over Q is equal to 16. This is like the key that they're giving us, right? So what I'm going to be looking for in my equation, once I simplify this all down, is I'm really looking for somewhere where I see P over Q, right? Because then I can just replace that with a 16, right? So that's kind of the idea. So it's like we're trying to make something so that we can turn it into something else, if that makes sense. So for the most part, like a lot of times you're just going to play around with these things, like using our log laws to try to see if you can get this out of it. Okay, so that's kind of the general strategy that we'll use. So this one, I can rewrite this as, well, first off, let's get that 5 on both of those. We'll put that up on both. So this would be the same thing as log base 2 of P to the power of 5 minus log base 2 of Q to the power of 5. Okay, what could we do next?
Put the negative one in the denominator.
Yeah, we could just use our log laws now to combine that as 1 and see if anything comes up here. So we'll have log base 2 of, and then we're subtracting. So what's that going to look like? Yeah, it'll be division is what I was going for there. Yeah, so that'll be P to the power of 5 over Q to the power of 5. Okay, which would really just be the same thing as log base 2 of p over q and then all to the power of 5. So do you guys kind of see that once we kind of played around with that, we ended up getting what we were looking for there, that p over q? That's why I was saying, like, this is like a key, right? So now, what am I going to do? Yeah, I'm going to get to replace that p over q with, so this would be log base 2 of 16 to the power of 5. Okay. Now, at this point, you could just put it into your calculator and get 20, but do you think we could figure this one out in our head? And maybe not yet, like the way it looks right now, because that's going to be like 2 to the power of something is going to be like this giant number. But why don't we just play around with one of our other rules? Why don't we move this 5 down front? So this would be the same thing as 5 times log base 2 of 16. So then this is really saying 5 times, and then what would 2, or log base 2 of 16 be? 4. Yeah, 2 to the power of 4 is 16. So that'd be the same thing as 5 times 4. So that's 20. I find these questions like satisfying because when they all work out, it's all kind of, you know you did it right. Yeah.
But then why do you get such a different number if you just put it in your calculator?
Oh, you wouldn't. Like if you guys actually plugged it in like this, you would get 20. If you're getting a different number when you put in your calculator, one place that you might be getting an error is if you had it kind of written like this, right? If it was log base 2 of 16 and then that was all to the power of 5, that would be different than what we're doing, because this is just 16 to the power of 5. All right, so let's do the next one. And you know what? I'm gonna let you guys play around with it because this one, like I said, it's like a puzzle. So see if you can work this one out. Okay, so if you're watching the video, just try to follow along with what we did there. All right, last one. So this one has a little trick to it. All right, so now they've given us like a bunch of keys, right? They've given us that log base 5 of 6 is equal to A. Log base 5 of 7 is B. Log base 5 of 8 is C. And they want us to rewrite the following logarithm in terms of A, B, and C. So when I go through this, what I'm going to be looking for is I'm going to be looking for log base 5 of 6s, log base 5s of 7s, and log base 5s of 8s, right? So I can like turn those into A, B's, and C's. So we want to rewrite this one, like just the general strategy here. So we want to rewrite as factors of, and then pretty much the numbers that we see there, we want to rewrite it in factors of 6, 7, and 8. And there's actually just one more. It'd be fine, it'd actually be good if I can find another factor of 5. So 5, 6, 7, or 8 would be good, because I'll show you in a second why that'll also be useful. But can we rewrite 30? Well, it's just, can we write this log base 5 of, and then 30, can I write that as any of these factors?
6 times 5.
Yeah, 6 times 5. So we'll rewrite that as 6 times 5 over, and then 56, can I write that as 7 and 8? Yeah. So 7 times 8. You guys kind of see where we're going here? So now we should be able to split this thing up, right? We can expand this as log terms for all these things. So let's write it out again. This would be the same thing as log base 5 of 6, which is a good sign, right? Because that's 8. Plus log base 5 of 5. Yeah, that's why I included 5. Yeah, if you guys see what that's going to turn into. Okay, and then minus log base 7 of 7. And then minus log base, oh sorry, 5 of 7, my bad. And then log base 5 of 8. And then we just, now that we have our key, right, that these are our keys up here, we just write them as what they were telling us it is. So log base 5 of 6, that's the same thing as A. So this is really A plus log base 5 of 5 is 1. And then minus log base 5 of 7 was B. And then log base 5 of 8 was C. So minus C. Like I said, so like if you got an answer like that, you're pretty sure you did it right.